Okay, today we're going to be starting with section 6-6, which is solving systems of linear inequalities. And we're going to take what we did in 6-5, which was instead of doing a system, we were just simply graphing a linear inequality and shading the appropriate regions and choosing the appropriate lines. This, in section 6-6, we're going to kind of kick it up a notch, and we're going to go to systems, which means we're going to have more than one linear inequality, and we'll need to graph each one and look for their solutions. So let's start off with this first one, and I'm going to do it in red. Let's rewrite it. The first step that we need to do is we need to graph points, and so we know that m equals 2 and b equals 3. So b is our y-intercept, which is at 3. And with this being 2, that's up 2 over 1. So our slope is up 2 over 1. Now that we have our points graphed, we need to determine what kind of line it was. This was step 3 of graphing any linear inequalities. And to determine the type of line, remember, if it's just a less than or greater than, it's going to have the dashed line. And if it's less than or equal to or greater than or equal to, it'll have the solid. So basically, if that solid line is in the inequality, then it will be a solid line. And if it's not, it's dashed. Since this has a solid line, we know that it's going to graph a solid line like that. We put our arrows on at both ends. Step 4 then was to pick a point and test it, or 0, 0, since it is not on the line, we can use that one, and that's always the easiest one to use. So now we plug it in. This is x and this is y, and we're going to plug it into that original formula. So y would be 0 is less than or equal to 2 times x is 0, and then plus 3. Well, 2 times 0 is just 0, and 0 plus 3 is 3. So we're asking ourselves, is 0 less than or equal to 3? Since it is, we would say that this is true, and that the point 0, 0 is part of the solution. So we would shade the side that 0, 0 is on, which would be this one. Now this is what we did in 6-5. Everything up to this point is 6-5. Okay? If you're confused on this, I'm going to urge you to go back to the 6-5 video and watch a couple more examples so that you know what you're doing there. Because now we're about to proceed into 6-6, which asks us to graph the second one, which we're about to. Before we do that, I just want to re-emphasize that everything in the shaded region is a solution for this first inequality. Okay? So any point over here, you could pick any random point. If you plug those into this first inequality, it will make that inequality true. Okay? These are all solutions. We're now going to do the same thing in green for the second one. Okay? So we need to know m equals -1 and b equals -6. So we're going to go down to -6. 1, 2, 3, 4, 5, 6. This is where it crosses the y-axis. Okay. And then we're going to go down 1 over 1 because our slope is -1. And we need to figure out what kind of line it'll be. Since it's just a greater than sign, we know that it is a dashed line. So that dashed line should keep continuing like this. We put arrows on both sides. We now have that line graphed. We then need to pick a test point. Again, 0, 0 works, so we're going to use that one. This is our x, this is our y. Is 0 greater than -0 minus 6? Now, -0 is just 0. 0 minus 6 is -6. So is 0 greater than -6? We would say, yes, that's true. So now that means that the point 0, 0 is a solution, so we would shade this region. Okay? Again, it's important to understand what solutions are and what are not. Because 0, 0 is a solution, we have the green and the red shaded regions. What we're now trying to find with systems is what is a solution to both. And the only portion that will be a solution to both, I'll kind of outline here in blue, will be the two areas, or the area where the two shaded regions overlap. So this area right here, if you pick any point in this area, you can plug those into both inequalities, and it will satisfy or make each inequality true. Okay, if you pick a point up here or off to the sides of that overlapping solution area, it won't satisfy the inequality. We're looking for this overlap. Okay, let's go through another example. We won't spend as much time because I think you guys understand the concept of the solution now. Okay, we'll start with the first one. We'll do that in red. Y is less than x minus 3. Our slope is 1, and our y-intercept is negative 3. So we're going to go up 1 over 1, up 1 over 1. We now have our points graphed. We have to figure out what type of line it's going to be. Because it's just a less than line, we know it's going to be dashed. So I'm going to go through, put my arrows, and we're good. Now we have to pick a point. 0, 0 is clearly not on the line, and so we can use that. We put our x and our y. So is 0 less than 0 minus 3? So is 0 less than negative 3? And the answer to that is no. So this is false. So we shade this region over here because the point 0, 0 is not a solution. So this area is not a solution to this. Now we move on with our green inequality. We know that our slope is 1 and our y-intercept is 1. So y-intercept is 1, and we're going to go up 1 over 1. At this point, you should be realizing that these two lines are going to be parallel. Okay, what kind of line will it be? We know that this is going to be a solid line because it has the equal to in the inequality. We're going to use 0, 0 as our test point. We're going to have x as y. Is 0 greater than or equal to 0 plus 1? 0 greater than or equal to 1? The answer to that is no. It's also false. So that means this point 0, 0 that we tested is not a solution, so we're going to shade the other region. Now this one is an interesting graph. Because these two lines are parallel and they're on the opposite sides or the shaded regions, we know that the shaded regions will never intersect or overlap. And so the answer to this one is actually no solution. We have portions of this graph that will satisfy the individual inequalities, but there is no part on the graph that will satisfy both. And so that's why we would say that it has no solution. Here are a couple examples. I hope this helps. Remember, the textbook also has some other videos. And yeah, we're going to do some more practice tomorrow, so good luck.